Hello everyone and welcome to Mathematics. So this video will discuss a 2023 trial paper from Kedah and will focus on the paper 2 questions. Alright, so let's get right into it. Question 1 comes from this chapter, System of Equations, and this one quite straightforward lah. We just need to find the values of x, y and z according to these 3 equations. Okay, there's nothing to let y'all know is that this is an acute angle, which means values of x, y and z all must be less than 90 degrees. So let us double check when we found the values of x, y and z. Okay, so now the problem is all of these 3 equations, they have the trigo function here. So how do we settle this? Okay, so for this one, I would suggest the fastest way is to just move the functions to the other side, which means you'll get something like this. And then you just type these 3 values inside the calculator to find the answer. So this is the fastest way, but it's not technically safe. So for the safer way, it would be using graph. Okay, so for sine and cos, as you can see, the values here both are 1 and minus 1. So this is actually a special case. So we can draw the graph out first and to find what is the value of x when we have 1. Right, so the sine graph is like this, right? And the value of 1 is here. So the value of x here is 90. Okay? And for the cos, same thing as well. Let's draw the graph. And minus 1 is actually here, the minimum point. Okay, so this one is actually 180. So our answer is 180. Okay, for tan, 1 is not a special case. Okay, it's not. So the way to find this one, you can use the calculator. Okay, another way is you can use the ASTC method, right? So this one is tan, this one is positive, so we can choose A and T. Okay, but here I will choose A. So if you use A, it will become 45 degrees. I wouldn't use T, right? Reason is because, right, this range is around 180 to 270. If you look at the equation, it says x plus y minus z. So we know that x plus y plus z, which means I add all these 3 angles, is 180. If I minus one of them, confirm it will be less than 180, correct? So I wouldn't use t because it's more than that already. Okay, so I will not use t, I will just use the a. So if it's a, we need to find the theta. So theta here is just arc tan 1, and we'll get 45. So this part actually involves the Form 5 Chapter 6 chapter, which is trigo equations. So I've prepared some videos about this. So if you want to understand more about the chapter, you all can refer to the links that I have attached in the video description. So if you have time, you can watch it. Alright, so now going back to the question, here we have 3 equations. So let's say put it as 1, 2 and 3, and to solve this one we can use the elimination method. The reason is because I would say this, compared to the other method which is called the substitution method, this method will be much faster. Alright, so let's go to the first step. Let's just choose x or y or z. So for this question, let me choose y. And the second thing is, let us make sure the coefficients is the same. So this means that if we choose y, let's just look at the values of y, regardless whether it is positive or negative. Okay, we just need to we just need to check the values only. Right, so here you can see all is 1. Right, so we are safe. But if it's not the same, let's say here it's 2. So when we go to the third step, which is to add or subtract, we need to make sure both of the coefficients is the same. So for the first equation, we need to multiply 2. Okay, but for this case we don't need to because all of the coefficients is the same. Okay, so now going to the third step, from these 3 equations we need to choose 2 out, okay, to add or subtract to eliminate eliminate y. That is our aim. Okay, so let me give you an example. So let us choose 2 and 1 and we minus 2 with 1. Right? And to eliminate y, we need to minus, right? Because if you use plus, this will be added together. So if you use minus, you'll get 2x equals to 90. So unintentionally, we also eliminated z, which is actually a lucky case. So we can straight find the value of x, which is 45. Okay, so this is just one. Let us find another set of equations and we use the third step again. So here, let us find maybe 2 and 3. So 2 minus 3, we will get this. And again, the aim is to eliminate y, so we need to minus. Right? So here, unintentionally, again, we also eliminated x at the same time. So we would find the value of z, which is 67.5. Okay, so this is very a lucky case, because most of the questions we wouldn't have this result. So sometimes you will get maybe, let's say here is 2z and here is 2x. Okay, so we have another 2 equations. So what we need to do is do the step number 4. So let us choose either x or z, make sure the coefficients is the same, and then we need to add or subtract these 2 equations to find either value of x or z. But for this case, we don't need to, because we have already found the value of x and z already. So we can just skip this step. Okay, and we can just go to the next step, which is to sub back and find the other unknowns. So this one and this one, I can sub it into the second equation to find the value of y, which is 67.5. And if we double check, these 3 values are all less than 90. Okay, so these would be our answer. And question 2 comes from this chapter, Trigonometric functions. And for these 2 questions, I already explained in my trigo function videos. So I'll put the video here to let you all refer. Alright? Question 3 comes from the circular measure chapter, and here we have 2 circles. So for the first one is the Kuala Lumpur circle, so the radius is 15. And the second circle is the London circle, so the radius is 8. So for part A, it tells us to find the difference between the circumference of the Kuala Lumpur circle, which is this red line, and the major arc of the London time. So major arc is the angle between the hour hand, which is here at the 3 o'clock, and this minute hand. Okay, the big angle, so it should be here. Alright? So now, if you want to find the circumference of the Kuala Lumpur circle, very easy, we just need to use 2 pi r, which is the formula. Alright, so the r is 15, so this would be 30 pi mm. And for the other one, which is the major arc of the London circle, so this one, it occupies 3 over 4, right? Because 12 to 3 is a quadrant, right? So we just need to multiply 2 pi r with 3 over 4, and the r is 8 for the London time, right? So this would be 12 pi, and to find the difference, we just need to minus them together to get 18 pi mm. So part B is a tricky one, because this designer wants to decorate using the shaded region here by placing the round shaped diamonds with radius of 0.76 mm. So it wants us to calculate what is the number of diamonds that can be placed. Right, so the first thing to note is that this shaded region is not the whole circle. You can see that here it's not shaded. So it only shades 10 out of 12 of the spaces. So here is actually 5 over 6. Okay? So the situation is, for the shaded region here, it wants the designer wants to place the diamonds here, okay, which has a radius of 0.76, like in this way. Okay, so the tricky part is, how do we know the number of diamonds that can be placed here? Okay, reason is because if I place a diamond here, I don't know what is the circumference, the part of the circumference that will be occupied by this diamond, right? Because you can see there are gaps here, so it's not very accurate, right? If we use the circumference line. So what we can do is, using this technique, but we change the line. Instead of using this circumference, we should form a line by joining the diameter of all these diamonds. Okay, reason is because firstly, I would be able to know what is the available space or the available length to place the diamonds, and I also know what is the length or the space that will be occupied by one diamond, right? Okay, so now the thing we need to do is to find the length first. Okay, so for this length, what I will do is using the 2 pi r, the circumference formula, and then I multiply 5/6. Okay, but here we don't have the radius yet, right? So let's find the radius first. Okay, the radius from diamond center to the center, which is here. So the original radius is 8, so minus the 0.76, you will get this value. Okay, so the new radius is 7.24. Then I can use this to calculate the available space or the available length to place the diamonds. Okay, which is 37.91 mm. Okay, so now to find the number of diamonds to place, now I have the available space, then I just need to calculate what is the length that will be occupied by one diamond. Okay, which is 2 times 0.76, because this one is the diameter, right? The circle's diameter. So if I divide these two values, then I will get the answer, which is 24.94, but again, this is maximum, so we couldn't have a 0.94 diamond, right? So the closest value that we can get is 24. Next question comes from the chapter Differentiation. Okay, and here we have a curve equation, which is this, and it passes through a stationary point A. Right, so for part A, it tells us to use the tangent sketching method, find the type of the stationary point. So in SPM, we learned 3 types of stationary point. So one is the minimum point, one is the maximum point, and the other one I think not much of students know, which is called the inflection point. Okay, so what is an inflection point? So recall back, stationary points are dy over dx equals to 0, or the gradient is 0, which means it is a horizontal line. So these points are on a horizontal line, and when the line passes through this point before and after, the gradient remains unchanged. Okay, so for example, this one, right? Before, the line goes down and the gradient is negative lah. After that, the line still goes down and the gradient is still negative, right? So the gradient remains unchanged throughout. So this one is the same as well, but the opposite lah. So the gradient, the line goes up throughout. So this also means the gradient is increasing throughout, which means the gradient does not change. Okay. And for stationary point, don't be confused by another term which is known as the turning point. Okay, so turning point only includes minimum and maximum point only. It does not include inflection point, right? So going back to the tangent sketching method, here we need to have a table first, right? So we have 3 rows, the value x, dy over dx value, and the shape according to dy over dx. So later I will explain how to draw the shape. Okay, but here in the column section, in the center here, we need to insert the info for stationary point first. Okay, so the x coordinate for the stationary point is 6, so we put it here, and we know that this is a stationary point lah, so the dy over dx will be 0. Right, so what we need to do now is to put a value which is less than 6 and a value which is more than 6. Okay, but I will suggest to put a number which is close to the value lah, which is 6. Okay, so here I'll put 5 and 7. So what we don't have is the dy over dx value where x equals to 5 and 7. Okay, so to find this, we need to differentiate the equation first lah. Okay, so for this one, you can see that it's like 2 things are multiplied together, so we can use the product rule to help us differentiate. So this part it will be u, and this part it will be v. And then we need to separately differentiate. So this one we just take the value, which is -1. This one we need to put the power to the front. Okay, so everything here remains the same, and then power need to -1. and then we need to differentiate the function inside here. So 1 over 2x here, we differentiate, just take the value, negative 3, it will become 0. So here we do multiply 1 over 2. And then product rule means we need to multiply, cross multiply here, and this one with this one. Right, so this is the differentiated equation, and now I will type this into my calculator. Okay, so I typed out already, then I will just press here, calculate, and then I will insert a as 5. Okay, so now you can see this is negative. So if I put 7, this is also negative. Right, so here we only need to know is it positive or negative only. We don't need to insert the value. Okay, so here I will just put negative, negative. Okay, so how do we draw the shape? So this one is quite easy actually. So negative, we know that the line will go down, correct? So here we just need to draw this. Okay, same goes to 7 as well. So 6, we know that it is a stationary point, so the gradient is constant, which means it is a horizontal line. So you can see the shape, right? Goes down, remain the same, goes down. So this is actually an example of inflection point, right? And for part B, in x, there is a small change by 1% when x equals to 2, and we need to find the percentage change in y. So to find the percentage change, we have a formula, which is this one, right? So in terms of y, we need to find these two things, delta y and y. Okay, this y is the original value of y. Right, so let's focus on delta y. How do we find this? Well, we have a formula, which is the small changes formula. So delta y over delta x approximately equal to dy over dx. Right, so to find delta y, let's move delta x to the right side. Okay, and again we need to find another two things lah, dy over dx and delta x. So this one, we can find it from the result that we got in part A, right? Just this one. And for delta x, usually it will be given in the question, but this time it's not so direct because x only gives us the percentage change in x, right? So this is the percentage change, so we do use back this formula, right? So the percentage change here is 1%, so convert to decimal, this is 0.01, and this is what we need to find. So this value of x is the original value, which is this, so here would be 2, and multiply 100%. So by rearranging, you'll get delta x is 0.02, so you'll multiply here. And there's another thing to note, that for the dy over dx part, you can see that there are x here, right? So all the x we need to sub the original value, which again is 2, right? So once you sub, you will get the value is negative 0.08. And this one, y is the original value of y, but since we already have the original value of x, so it's easy. We just sub this value to the original equation to get the value of y, which is 16. So your final answer would be negative 50%. Next question comes from the factors chapter, right? So there's a lot of information here, so I will explain and also draw something on this diagram at the same time lah. Right, so if we look at the distance from the teacher's desk, which is G, to the student desks, so from A will be 4 meters, B will be 8 meters, and from C is 4 meters, from D is 6 meters, right? And also it says that there's a ratio, GE is 2 parts, and GF is the whole line is 3 parts. So this means from E to F, there will be 1 part, right? And it says that BF is equals to FD, so this means F is the midpoint, alright? So now I will duplicate this diagram here so we can solve this question easily lah, right? So for part A, it says that vector A represents 1 meters in the direction of GB, right? So let's look at the line GB. Okay, so the 4 and 8 I can convert it into vector, right? In the direction of GB, 4 will become 4A, 8 will become 8A, because 1 meter represents 1 vector. And for B, vector B represents 2 meters in the direction of GD, right? So this 4 and 6 I can convert to 2B and 3B respectively. Okay, so now we need to find the vector BD. So this means you are here and you need to reach this point, right? So I don't recommend you all to go to the short way from B to F, F to D, because there's no vectors here. We don't know the vectors yet. So what we can do is choose the routes that have the vector, right? So I can go from B to G, because there are a lot of vectors here, and G to D. Okay, so let's write out the path that we want to go first, because this one for sure there will be 1 mark. Okay, so going back to the diagram here, B to G, the vector is opposite of this vector 8a. So here we need to write negative 8a. Okay, and for G to D, the vector is graduated forward because it's in the same direction as we want to go. So this would be 3b. So negative 8a plus 3b. And for the next vector is EF. So EF means we need to start from here and we need to reach F, right? But there's an issue with this, because this line, there's no vectors. Let's say if I want to go from E to G, there's no vector, right? So let's change our starting point a bit. Instead of starting with E, let us start from G. That'll be better, right? Because G and F is the endpoints of this line. So it will be much easier to find the vector, right? So now to convert the starting point from EF to GF, we need to use the ratio lah. So EF is 1 part, GF is 3 parts. So this means that EF is 1/3 parts of GF, right? Okay, so now let's find our route. So we can go from G to B and B to F. Okay, so this is our route. So for vector GB is easy to find, which is 8a, and BF is also easy to find because we know that F is the midpoint and we know that the whole line's vector already in part A1, right? So what we need to do is just using this value, divide by 2. And by simplifying, you'll get 4/3a plus 1/2b. Right, going to part B, I have remained these relevant information for this question lah. Okay, so here it also gives us some additional information where AE and GC is parallel, and the distance between A and E is 2 meters, right? And the big triangle area, which is GBC, is 25 meters square. So now we need to find the area of triangle of the small triangle ABE. Okay, so area of triangle, we can use this formula 1/2 times base times height. But for this diagram, as you can see here, we don't have the height for this small triangle. Alright, so how can we find H? So actually we can use the ratio way. As you can see, for these two lines, right, both of them are parallel, both of them are the base of their respective triangles, right? So if we know the big triangle's height, we can use the ratio, convert to the small triangle's height, right? Okay, so firstly, let's find the height of this big triangle first. So area equals to 1/2 times base times height. So area is 25, base is 4, so H is 12.5 meters. Okay, so now we find the ratio of this small triangle's base and the big triangle's base. So it will be 1:2. Right, so here means if the big triangle's base, height is 12.5, so we just need to divide by 2, which is 6.25. And then we can find our area, which is 1/2 times base is 2, height is 6.25. And then we'll get 6.25 meters square as our answer. Question 6 comes from the chapter functions, and here we have a quadratic function with modulus, and t is between -4 and 4. So part A1, we need to sketch this graph. Okay, so here let's ignore the modulus first, and let's just focus on t squared minus 16, which is a quadratic function lah. Okay, so how do we sketch these kinds of graphs? So we need to have 3 things. So the first thing is to find the start and the end points. So we know that this graph starts with t equals to -4. So let's find out the coordinates first, right? So we just need to substitute t with -4 to get the coordinates, which is -4, 0. Same goes to the end point as well, which is 4, 0. Okay, so the second thing we need to find is the intercepts, right? So for the x-intercepts, we know that for any quadratic graph, right, maximum there will be only 2 x-intercepts, right? And also the x-intercept, the y-coordinate is 0. So if you see here the start and the end points, we actually already found them, right? We have 2 of them, and the y-coordinate is 0. And the y-intercept here is negative 16, because we know that ax squared plus bx plus c, which is the quadratic function, c represents the y-intercept. So if I compare here, c is negative 16. So the point is 0 minus 16. Okay, and the third point is to find the minimum or maximum point. So let's analyze the function here. So we know that a is more than 0, so it will be a smiley face. But here we don't have b, right? Because there's no value which has the x only or the t only. So it is 0 lah. So if b equals to 0, this means that the middle line or the axis of symmetry of this curve is the y-axis, right? So here, this means that the y-intercept is actually the midpoint of this graph, right? Okay, so here we don't have to find this point anymore lah, because we know that y-intercept is the midpoint, so this is the midpoint, 0, negative 16, right? So let's plot these 3 points in this graph. So if we join them, it will be something like this. But remember that we need to apply the modulus. So everything which is below the x-axis, or here the t-axis, we need to reflect to the top. Okay, so use the t-axis as the mirror. This is our image. And don't forget, this negative 16, we need to change it to the positive value lah, because we reflect upwards. So everything which is negative need to change to positive. Alright, and for part 2, we need to find the range of t where this happens, ft more than equal to 7. Right, so let's substitute our function. Okay, and this we can move the modulus to the right side. So we will have 2 results. Okay, one is the positive one is the negative one. So you can see if we put negative to the right side, this will change. The sign will change. Okay, so let's focus one by one. Okay, so if we simplify, we will get this one, and we apply square to the other side, we will also get another 2 results, right? So if we change these 2 values to the decimal, we will get 4.79 as negative 4.79, which is an issue because our t can be only negative 4 to 4. This has already exceeded, so we need to reject, right? But for this one, if we move the square to the other side, okay, and we simplify, we will get t is less than or equal to 3, but t can be more than or equal to negative 3. Okay, so it's within our range, right? So we can also combine them together, this condition. So t is between negative 3 to 3. And for part B, we need to find the range of f using the same interval of t, right? So range depends on the y-axis. So here we need to find the minimum and the maximum value of the y-axis. Okay, so the minimum value is 0, which is here, and the maximum is 16, right? So your range should be written in this way, okay, the range way. And the middle, make sure you put ft, not y, right? Because the function here says ft. And for part C, if the range of t is different, which is 0 to 4, we need to determine whether the inverse function exists or not. Okay, so let's change the function, let's change the graph a bit, right? So if we want to check whether inverse function exists or not, we can use a test, which is the horizontal line test. So if I use this test and it intersects 2 or more points, this means the function is not an inverse function. Alright, so let's apply this test onto here. So you can see that if I draw this horizontal line, no matter where, it will only intersect 1 point. So is this an inverse function? Yes, because it does not intersect more than 1 point using the horizontal line test. Okay, so don't be confused with another line test, which is the vertical line test. So this one only detects whether that function is a function or not. Right? So the same thing as well. If it intersects two or more points, it is not a function. And question 7 comes from the chapter Coordinate Geometry, and here we have three houses, Aman, Damai and Sentosa, and for part A it tells us to find the area bounded by these three roads. Okay, so if you go to the formulas in Coordinate Geometry, I think none of the formulas can help us find the area if we only have these lengths, right? So we need to use formulas from another chapter, which is Form 4 Chapter 9, Solution of Triangles. Okay, so don't be surprised you may be asked to use formulas from another chapter which does not appear in section A. Right? You know that Solution of Triangles, the chapter appears in section C, but don't be surprised because sometimes some questions they would tell you to use those formulas. Right? So to find the area, we have two formulas from this chapter. Either is the first one or the second one, which is known as the Heron's formula. Okay, so here we only have the lengths, so we cannot use the first one because it requires the angle, right? So we can't use this one, so we can use the second one. Right, so let's calculate the S first, right? So add all the lengths and then divide by 2, which is 8.65, and then we can calculate the area bounded. So the first thing is we put the S, and then we multiply the differences between S and each of the lengths, right? And then you'll get the area, which is 8.486 km squared. And part B tells us that this developer wants to build a road at a minimal cost which connects the guardhouse in Taman Aman, which is this one, and Balai Raya. Right? So Balai Raya here locates between the road that connects Damai and Sentosa. Right? So example, this Balai Raya might be here. So how do we find the length of this road which wants a minimal cost? Right? So road which has a minimal cost means the shortest road lah, right? So how do we find the shortest road? Okay, very easy. We just need to find the road that connects Taman Aman, and it must be perpendicular to the road that connects Damai and Sentosa. Okay, so this is a fact. If we want to find any kind of things which has the shortest or the smallest, we can use perpendicular to help us. Right? So why perpendicular? Right? Let's say if we are not using perpendicular, so let's say we draw some random lines. Right? So now you can see this line and this line, this red color lines, is like if we form a triangle like this, these two lines are the hypotenuse, right? And we know that hypotenuse would be always longer than these two lines, correct? So these two red lines are longer than this blue line, so this means this blue line would be the shortest. Okay, so it's like, I give a real life example. Let's say you are trying to cross the road. So what is the best way or the fastest way to cross the road? Which is to go straight, right? You are here and then you just go straight, right? So it's the same concept. We use the perpendicular way to find the shortest road. Okay, so now how do we find the length? Right, actually we can use the result that we got from part A, right? Because we know that the triangle's area already, and we also know the base, which is 8.06 km. So we can use this formula. Area of triangle equals to 1/2 times base times height, right? So for all the information, let us put inside here so we can find the height, which is 2.106 km, or the shortest road. And for part C, we have the coordinates for Taman Sentosa guardhouse, which is 5,4, and Taman Damai's coordinates as well. Okay, so here it says 2 km from the origin, so this means we need to go 2 units to the left to reach Taman Damai. Okay, so the coordinate is -2, 0. And now we need to find the equation of this line in this intercept form. Okay, so for line equations, we have 3 types in this chapter, coordinate geometry, which is gradient form, general form and the intercept form which the question requires, right? So D and E here represents the x-intercept and y-intercept respectively, right? So the x-intercept we have already found, which is this one, -2, but the y-intercept here we don't have any information because here it doesn't give us the line equation, right? So no choice, we need to form y equals to ms plus c equation first. Okay, so value of m, okay, so we let this as the first point, this as the second point, we just use the formula and we'll get the gradient, which is 4/7. Then we can use this formula, this form, y equals ms plus c, use this as the point and this gradient, and we will find the value of c, which is 8/7. Okay, so now we have these two intercept values and then we can sub it here. And we simplify a bit and this would be our answer. Going to section B, so the first question comes from integration, and here we have a gradient function. So please remember, gradient function is dy over dx, right? So in this diagram we have a line and a curve and the shaded region lah, right? So for part A, we need to find the equation of the curve, the original equation, right? So here we have a dy dx. If we want to find the original equation, we need to integrate this, alright? So for this one, the square root, I change it to 1/2, okay? Then I move this thing to the top. So you can see that the power here becomes -1/2, right? So let's integrate this. Right, so this value, I will put it out from the integral first. Okay, and let me integrate the things here. So here, x minus 4 power at 1, so here will become 1/2. And let's divide the new power. And then at the end, we plus c. Plus c because the limits are not given. Right? So here, 1/2, 1/2, we cross off. So the final result would be this, right? But here we need to find the value of c, so very simple, we can just use one of the coordinates from this line, which is q, and we just sub it here to find the value of c, right? So here by rearranging, c is equals to 0, so this would be our final answer. Alright, for part B, we need to find the area of shaded region. So the technique that I always use is the big shape minus the unimportant small shapes. Right, so the big shape, I would say for this question is here. Okay, this area is actually area under this curve, and it is bounded by the x-axis. Right, so let me find the values, sorry, the minimum and the maximum values for this area. Right, sorry, the minimum and the maximum values of x for this area. Right, so the minimum is 4, and here, since the x coordinate is 13, so this would be 13. Okay, and then we need to minus out the small shape, which is this small triangle, right? Okay, so again, we need to find the lengths lah, but firstly, we need to find the coordinates, right? So this one is 13. Okay, and this one is this line's x-intercept, so we need to put y equals to 0, so this would be 10, and here the points would be 0 and -3. Okay, so we have already found the points, and then later on we can find the length lah. Okay, so to find the area of shaded region, we need to minus these two areas. So for this one, it is bounded by the x-axis, so here the x and the x values 4 to 13, and we need to integrate the equation of the curve, which is from part A, right? So let me put it here. Right, and the triangle, so triangle will be 1/2 times base times height, so 13 minus 10 is 3, 0 minus -3 is also 3. So to integrate this one, negative x minus 4, this one we do plus 1, so this is 3/2, and then we need to divide the new power. And later on we do sub 13 and 4, and this one, if we simplify, this will get negative 9/2. So when you substitute 3 and 4 inside and you minus the values together, you get negative 18, right? Reason is because this area is under x-axis, right? So this is a fact, right? Below the x-axis, the area would be negative. So what we need to do is we need to add modulus, right, for all of the steps, including the first one, right, to let negative to become positive, right? So if we minus these two values together, you will get 27/2 units squared. And for part C, we need to evaluate this expression. Okay, so let's us plug in the f of x first, right, which is this equation, and then we have a square here. So let's square this negative, so negative, negative, positive, so this one will disappear, and this as well. So here 2 and 2 get crossed off, so we have left x minus 4 only, right? So x, if we integrate, it will become x squared, which is the new power, divided by the new power, and then for the 4 we just add the x, right? Later on we need to substitute 10 and 4 inside and minus the values. Okay, so this is the value for, if you sub 10, this one is when we sub 4, and by minusing together you will get 18 pi, right? So what are we trying to calculate here? So this one, if you see, we have pi in front and a square. So these two things are a sign that we are actually calculating the volume. So if you look at the volume, the formula of the volume, you can see that here we have pi and a square, which is exactly the same thing here, right? So this is, sorry, we are calculating the volume, so here we need to add units cubed. Next question comes from the chapter linear law. So here